This is an ATP question on magnetism. When freely suspended, a bar magnet will come to rest pointing in a north-south direction. Which pole of the bar magnet points towards the geographic north of the Earth? We consider it north actually. By rule, it should be the south, but it is a convention that the North Pole points to North Pole of the Earth and South Pole points to the South Pole of the Earth. So you will write North Pole. In order to find the direction of geographic north, the magnet must be able to rotate freely in a horizontal plane. So remember, there were two methods: either hang it from a string or tie it on a wooden block and put it in water. So there are two options. So you can use this method. Now copy this diagram.
Done.
Right under it, arrange the apparatus as shown. Arrange the apparatus as shown. Allow the bar magnet to swing freely. Allow the bar magnet to swing freely.
Done.
Now read the question. One student suggests floating the magnet on water. Describe how the magnet can be supported on water so that it is able to rotate freely. Already I had explained that put the magnet on a wooden block, otherwise the magnet will sink. Put the magnet on a wooden block and tie it there so that it can rotate freely. So draw this diagram.
Done.
Right under it, arrange the apparatus as shown. Arrange the apparatus as shown. Tie the magnet by a string. Tie the magnet by a string hmm, state and explain which of the methods in B allows the magnet to stop rotating in the shortest time. Now, do you think the magnet will stop quickly in air or it will stop more quickly in water?
Water.
Water. Good. So, because water is a denser medium,
There will be more resistance.
yes. So, write under it that method in B part 2 method in B part 2 will stop the magnet in the shortest time. Method in B part 2 because water is a denser medium compared to air. Okay. Can you look for another question now?
Okay.
A student using a plotting compass to plot the pattern of the magnetic field between the north pole of two bar magnets. A student places the magnets on a sheet of white paper as shown. Okay. Describe how the student uses the plotting compass to plot the pattern. I think we just studied this, repeated this in the first question today, that you have to put the compass near one end of the bar magnet and then move the compass around the bar magnets. So a student uses A plotting compass to plot the pattern of the magnetic field between the north pole of the two bar magnets. We should move the compass like this. So first copy this diagram.
Of copy.
So write under it that this write under it that uh, place the compass near the north pole. Write under it, place the compass near the north pole of a bar magnet
On.
place the bar magnet, near the north pole of the bar magnet. Mark the position of the needle. Move the compass as shown.
On.
Move the compass as shown. Mark the positions. Mark the positions. Remove the compass and join the dots. State what else the student can deduce about the magnetic field in this investigation. Same question, and you had already answered it. So what can you deduce in further here? What did you say before? Direction and
Our strength.
direction and strength. There is another question on magnetism. June 21, 4. A student investigates the magnetic field between two strong magnets. Two strong magnets. She places the magnet as shown. So she places the magnets on a smooth surface using pieces of adhesive putty used, for example, blue tack or petafix, as shown in the figure. Suggests why the pieces of adhesive putty are needed, because they are like poles. South pole is facing south pole, so they will repel each other. So if you do not put any adhesive, they will move away from each other. So write down the answer for part A. Like poles repel each other. As like poles repel each other, the magnets can move away, magnets can move back. Describe how she uses a plotting compass to plot the pattern of the magnetic field between the magnets. You have just done it, this thing twice or thrice with me today. So you can see what you have to do. You have to put the, how using a plotting compass to plot the pattern. You will tell examiner that put the magnetic compass near a pole like south pole of a bar magnet, and move it towards the other magnet and start plot marking it. So suppose you put the compass here and you move it forward, it will show a downward motion, a downward pointing. Then place the compass here. So you will place the compass on different positions. The space is quite low, but I hope you can look at this. He places the magnet on a smooth, sorry. Now, first copy this, update the same diagram, update it.
Done.
Now, write under it that place the compass near a pole place the compass near a pole, mark the position of the needle, mark the position of the needle, move the compass between the poles as shown,
Done.
move the compass between the poles and shown as shown, remove the compass and join the dots and join the dot, remove the compass and join the dots. On figure 4.1, draw the shape of the magnetic field that she observed inside the box. This is a repulsion pattern. Now you have to copy this.
Done.
is